Okay, hi everyone. Welcome to a research working session, which is somehow a combination of theoretical consideration of multicomputation with our way of making that concrete in Wolfram language. So I think we've got two things that have been making progress. One is the multi initiative of Nix. And I don't know, Ian, have you been progressing Tracegraph further?
Yeah, so Tracegraph now supports the pattern in the second argument and all options of trace.
Okay.
And there were some formatting updates.
Okay. Well, let's see. Should we? Well, I mean, that may be much simpler to look at. Can we? Is there a nice picture to see there?
Sure. Open any of those example sections.
So this is now showing how f of 1, 2.
Sorry.
This edge is. I don't understand what this is. This is a reassembly edge here.
Mm-hmm.
This is a recursion edge, and this is a derecursion.
Yes.
Is that correct? Do we have a notion, Nick, in other things you're doing? Do we have this notion of derecursion? What is this?
I mean, reassembling the expression from its pieces.
Yes. Oh. Yes. I mean, that's a concept that in our usual multi-way analysis we don't really have. Am I right? I mean, that.
Well, I've tried something like that by hacking some of the options for the token graph, for example.
Yeah, what about is it recombination, Nick?
Yeah, that's it.
Yeah.
It's like if you have tokens somehow annotated with position, then you can reassemble a bunch of tokens into an expression. And if there is a token that occupy the same position, multiple tokens that occupy the same position, you kind of make different states. So they branch naturally like that.
So wait a minute. So let's take a look at this, for example. Okay, so here we've got F1. Okay, so this thing doesn't maintain in the ports from here. It's not maintaining the order, which is a little bit confusing.
It should.
Okay, fine. Okay. So then this has its deconstruction and its reconstruction events. And then this reconstruct. So these are all things where no evaluation took place, where it's just there's just an examination. So what this is basically is the inverted version. So this is the tree up here, and then this is the inverted tree, correct? Down here.
Yep.
It's two trees glued together. Okay. So let's take a look at evaluation here. Okay. 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 A little bit confusing because it isn't in the same order in the tree branches here. Okay. So this is then the reconstruction event. So we've got two kinds of edges. We've got evaluation edges and deconstruction, reconstruction edges. Is that correct?
Yep.
Okay, so those are the two forms of recursion that we've talked about endlessly. Recursion through an expression and recursion by evaluation. Okay. What's that?
So those are placeholder nodes for when you're using patterns or when you're using trace original goes to false.
I don't quite understand that. That's well, let's look at this one here. So this is Y. examines the y, turns into x, turns into 1, and is reconstituted. Okay, I get it. Okay. I understand. Now, the foliation of this is not totally obvious. That is, the fact that the x, you got what I'm saying? That what the simultaneously existing expressions are. Clearly our evaluator is sequential, but were this to be done in parallel, you could foliate this differently. Am I making sense?
Mm-hmm. Basically depth first versus breadth first.
Well, for example, but you could just draw foliation lines. So the simultaneity line could either have a state where you have, you could have an X and an X existing, coexisting,
right.
Or not, as the case may be. And in a sense, if we had these things being run in parallel on different processors, depending on how those processors were running, you would get different intermediate states.
Yes.
Okay. These are nice pictures. Can we see some more non-trivial examples? Ah, look at that. Be careful what you ask for. Okay, so this is going to show. Okay, let's try to understand what's going on here. So that's the first. I don't understand why this. I see. First it recurses, then it does the evaluation step. Is that correct?
Yep.
And then this is again deconstructed, although the order of deconstruction is kind of, it's a plus, the 4 minus 1, and then the 4 minus 2 foliates bizarrely all the way down here. Why does it go all the way down there? Why isn't it pulled up to be at the same?
This is whatever layered graph plot does automatically.
Okay, so, but we need to understand that, because in terms of thinking about this in parallel, so to speak, these two things could be evaluated, could occur, they sort of exist at the same time. The fact that we went through and we've already got Fibonacci of 3 minus 1 before we've got in the foliation that we're showing here, fib of 4 minus 2, is a little odd.
Right.
See what I'm saying?
Yeah.
All right, I think I more or less understand this picture. Do other people understand this picture? I mean, now,
can you look at the non-standard evaluation section?
Yeah, but here, okay, so this is a full evaluation graph. We're clearly going to want to prune down this evaluation graph.
Right.
For example, one optimization. I mean, if we think about, one optimization here would be to remove the self-evaluation sub-pieces.
Yeah, so if you scroll down, that's the next graph. This is with trace original goes to false.
What does trace original do?
Trace original compare. So the second argument is a pattern, and trace original goes to true means that you compare that pattern before and after evaluation. With trace original goes to false, you only compare the pattern after evaluation, and you don't include things that evaluate to themselves.
Yeah, I don't understand this. Why don't I see fib of 4 minus 1 here?
That's that node. That's that node there, the unlabeled node.
Why isn't it labeled? Doesn't it know that it can be labeled, so to speak?
Not with trace original goes to false.
But it can always be uniquely labeled, correct?
Mm-hmm.
With an expression.
That exactly corresponds to the same node in the above graph that does say fib of 4 minus 1.
Okay, so I mean, to me, that's sort of a bug in the trace graph, that it should say fib of 4 minus 1 here. Why wouldn't it say that? I mean, I understand, as you extract the information from the trace function.
Well, so I'm not showing any examples here of the second argument, but there's a futurized ref page. The second argument can be a symbol or a pattern, and they're handled subtly differently. And that basically controls which things are labeled and which things aren't.
Okay, but I mean, to me, whenever you see a line like this, I don't understand why things aren't always labeled. Because there is a unique thing that is there, right?
What I'm saying is it's a matter of the options that you're specifying. If you said, for example, trace above goes to true, that would be labeled. It's just an
Okay.
option setting.
Okay, but why would you ever not want it labeled?
Ian, isn't it the case that you are showing here the expressions that appear in the trace? And so you don't put anything there because it's not in the trace?
Yeah, I think that's what's happening. Right. But I'm saying that this, what we designed and traced in 1990, I mean, who knows whether
so what I'm doing here is I always have each evaluation chain starts with a round node and ends in a square node.
Right. So I'm saying each evaluation chain should say what it's evaluating. Always. There's no reason not to do that. See what I'm saying? It's just confusing to see this. Right? I mean, I don't care that trace doesn't do it. I mean, that's a bug in trace as far as I'm concerned. Because we just had way less understanding of how trace was going to be used back, 32 years ago or something.
So we can survey the options of this and see if maybe some of them need different defaults.
Yeah, I mean, I'm telling you, this should be labeled. I don't understand why you would ever want a graph like this. I mean, you might want a graph where nothing is labeled just because you just want to see the structure. Get what I'm saying? But I can't see why you would want a graph where there's partial labeling.
Let's say if the second arg is like blank plus, then you'll get a graph where you have unlabeled nodes that are just showing you like the topology of the evaluation, but you only have labeled nodes that match the pattern.
I understand. I'm not sure that's the right way to do it, but I understand that argument. But this isn't, in the case where you have a chain like, I think you should always label the thing that you're evaluating. Anybody else got opinions? Christopher, do you have an opinion about this?
Yeah, I mean, I kind of think also that it seems like you probably want all or nothing.
Right. I mean, what would this look like? I mean, so if let me just evaluate this. This is, by the way, very nice. What you've got here, Ian, just to say that. Thanks. I mean, I don't think it's quite there, but it's getting there. It's really getting there. So if I do this, okay, where's fib defined? And by the way, I want to see what a memoized function would look like. Okay, so if I do this, and now I say, why do I need to do the trace fib? I don't need to do that. And now how do I get this with no labels, just to see the topology?
Interesting.
Why didn't that work? Why didn't that work? What the hell is this? Fib of 4.
Maybe I copied and pasted the code wrong into the notebook. Let me check.
Something's wrong here. Does this need a prototype build?
No.
What's this arrow cheese tree? Well, that must be some whatever. Okay, what happened here? Do you want to send me a different notebook?
Yeah. Give me a moment.
Okay. Okay, and by the way, well, I want to take this graph, and I mean, the aspect ratio is kind of crazy. Why is it making that aspect ratio? Did you tell it to make that aspect ratio?
Nope. Default aspect ratio.
Okay. Okay. So I'm still trying to understand. Well, we're going to get to this in a minute. I want to see what the overall structure of this graph is. I mean, I should see a Fibonacci tree here. And then I'm going to try a much less savory recurrence. And I want to see what that looks like. Okay, you're going to get this result, or should we turn to a different thing and come back to this later? What's the story?
Come back to it.
Okay. Okay, so what is this? This is with hold. And what are we seeing here?
So with the hold, you're seeing that you have deconstruction edges, but you don't have deconstruction edges for the arguments.
So you're saying it's not a full tree. Is that what you're saying?
Yeah, basically, because of the hold of 1 + 1, the 1 + 1 never gets broken out into a tree.
Okay, so this here, hold of 1 + 1, gets the hold. This is super confusing.
Right, because the hold evaluates, but the rest doesn't.
You know, we need a way of indicating a deconstruction or reconstruction edge separately.
Mm-hmm.
Anybody got an idea for that? I mean, it's kind of I mean, it's almost like arrows, but we don't want arrows pointing in the wrong direction. Nick, you haven't solved this problem in some other way, have you?
Not really. It should be an arrow, I guess, yeah.
Yeah, but it can't be an arrow pointing up, you know, so this is kind of a downward pointing. This is a deconstruction edge. And this is a reconstruction edge. And
Maybe
this whole thing is a directed graph. Go ahead.
Well, maybe there should be an arrow from hold in both directions.
Yeah, I know, but that will mean that there's the arrow is not following the time-like direction, which is confusing. See what I'm saying? I mean, gosh, what could we indicate?
Well, if you want it to be a DAG, you don't want to add arrows. I mean, what other options do you have besides just styling it color-wise or something like that for the edges?
Well, I mean, I think it should be some iconic thing, but not an arrow.
I see. Okay.
What could it be? People, what could we do here? So let's look back at another.
You could always do a different. Can't you use edge shape function and have like other styles of arrows, or having like
definitely,
you know, the little arrowhead in the middle and stuff like that?
Definitely,
it might be confusing to have multiple types of arrows.
But what should it look like? I mean, we can have an edge shape function, but what should it actually look like? What is the correct thing that's going on here as this breaks down into those pieces?
What about an edge that increases in width, so that deconstruction is some sort of lens that increases in width and then reconstruction decreases in width?
So you're suggesting that it tapers from wide at the top to narrow at the bottom?
I would say the other way. I mean, to me, the deconstruction is like a lens that you want to analyze. So you go deeper.
I see what you're saying. So it flares out at the end. I mean, we could even do something maybe where, well, sometimes you want an arrow at the end. So you're suggesting that we could try that. I mean, you're suggesting that the thing widens slightly.
Mm-hmm.
I'm a little concerned that when it gets small, that's going to be hard to see. But I agree that that's conceptually, we should look at that. And if you're able to just like, I mean, it should just be an edge shape function. See, it may get very weird on a really long edge like this, what it's going to do. And we may be better off with something that is some kind of bead that's on the edge. I just don't quite see how to do that. Well, let's take a look at what we can. Okay, so we're going to need something like that. Okay, so here, this is atomic and has no, I mean, we could have a stub. I mean, in a sense, there's a self loop here. Is that not correct?
In what sense is it a self loop?
Because it's going back to itself. It's not being deconstructed. Or your argument is the failure to deconstruct is just there isn't deconstruction, rather than it deconstructs to itself.
Well, so right, like the head could have been like F, and F evaluates to hold, and then there still would be no further deconstruction for the arguments because the head has a hold attribute.
Okay.
Right. It still has to, deconstruct in the sense of it has to evaluate the head.
Yeah, you're always going to deconstruct the head.
Okay.
I sent you an email with the code.
Okay, great. Do I ignore the fact that it says that it needs to be here? Why did I put that in this file since we're should I just delete that there?
Yeah.
All right, let's see if anything works here. What's going on?
Are you sure you evaluated all the cells? You only evaluated the top cell. I'm not sure if it's all in one cell though.
It seems to all be in one cell.
Worked for me.
Maybe
Well, what
restart
version
the
are you
kernel.
running?
13.1.
Is there a reason not to just quit the kernel and restart?
Well, I'm not running 13.1 here. So, I mean, if you want me to be running 13.1, I can be. I think you're relying on some 13.1 feature.
Could you maybe just do like random tree of 10? Maybe tree isn't auto loading.
Well, I mean, I'm now running a completely different kernel, so. Okay, now we're working.
Okay.
Okay, so you should chase that down, but that's an issue, minor issue. Okay, so let's evaluate fib here. Okay, so now we got trace graph fib of 4. Okay, terrific. So that is now, what are these? These are just confusing things that shouldn't, okay. So now, how do I get rid of all the labels? Do you understand my question?
I'm not sure that there is an easy way.
Well, why don't I just go, what is this object?
The pattern, so the pattern you specify controls both the labels and.
No, I know. So I just want to take post-process this graph to remove its labels. Can I just do that? By
just do graph. It's just a graph. So
okay.
Vertex label.
Oh, no. That didn't work. Why not?
Shape function goes to none. I guess because I'm hard coding the shape function in a way that's not compatible with that option. Okay.
Come on.
It's maybe vertex shape function arrow blank, arrow none. That may delete those.
Yes. Okay, so this is now the topology of fib of 4, right? I don't really understand this topology, but let's try to understand it. And by the way, your dashed lines aren't fantastic. They have some kind of absolute dashing in them. I'm just complaining about that. Makes sense? Ian, you understand?
No.
Look, as I make this smaller, the dashes are somehow disappearing. I don't know.
Should get smaller as well.
I think so. I don't know. Does somebody here know how to do that?
I think dashed, they don't get smaller. And
Okay, so I
maybe
don't
there's
know
some weird option for that, but I doubt it.
Maybe thickness with scaled works, but I'm not sure.
Okay, who understands these pictures? Okay, so that's a big Fibonacci there. What the heck is going on in this picture? Okay, so what we should see is a Fibonacci tree. What are we seeing here? We're seeing a Fibonacci tree of deconstruction and another Fibonacci tree of reconstruction after that, or what?
Essentially.
Okay, so let's imagine we did this for factorial. We
You
should
see the self-similar structure, right? So if you start from the left,
Yeah, right.
left is like I think it's like the simplest one, right? And then you move a couple of steps to the right, and you can see.
yeah, it's spawning another critter in here.
Yeah.
Yeah, right.
Okay, let's just for fun, let's do a factorial just to make sure we understand what's doing. Okay, so
And this have like very similar structure to the causal graph. If you actually make a causal graph for this evaluation,
that's interesting.
it's just
Okay.
having a bit more edges there, because it includes deconstruction. But if you only leave the dashed edges, then it would be, I think, exactly the causal graph.
Okay, and this is kind of expected, right? This is just a pure linear thing.
Yeah, do trace original
Tail
goes to
recursion.
true.
Okay, so what the heck are we seeing here?
It's the decomposition into products.
Wait a minute, what's going
Oh,
on?
it's including the times or
Yes.
whatever. Yeah, I see.
Let's get rid of these for a second here. Okay, n goes to 3. Well, that's entertaining. You actually get to see the temporary binding of the table. It's kind of
I
interesting.
think what would be useful in general to be able to handle scale is to go to tooltips, or at least easily being able to specify to go to tooltips.
Yeah, I agree. And I mean, there's a bunch of labeling stuff here of what you should bother to label. Because I mean, if you just labeled some small fraction of these nodes, that would already be useful.
By the way, though, I mean that option about like vertex labels, arrow tooltip or something, that would be useful generally.
Yeah, this needs to play nicer with graph options.
Right, but that's a suggestion. Vertex labels arrow tooltip will be a suggestion for Charles. For graph.
It already works. I think it works with placed. It's like I usually do vertex labels, goes to placed, automatic, and as a second argument, tooltip.
Oh, really?
I didn't know that worked.
So you're saying if I do this here, and how would I do that? Let's do it here. So you're saying in this picture, what would I do, Nick?
Instead of none, you just say placed, automatic, comma.
In this one or in the vertex shape function?
I think labels would do it because it's automatic. If the actual vertices are the expressions, then it should work. So tooltip.
Yeah, is there a difference, by the way, between vertex labels arrow name and arrow automatic?
No, I don't think so.
Yeah, I think it's the same.
Oh, there we have it. Why is
Right.
that 17 and 20?
I don't actually specify vertex labels. I just do the whole thing in the vertex shape function.
Oh, I see. So these are just indices.
Yeah.
So we really have to do in here, we should put in this place thing. Is that correct?
Yeah. if that works.
I don't think it's going to work for the
I
shape
would
function.
be, yeah.
It's not going to work for the shape function.
Oh, I see. It's got to have more detail. Okay, so we maintain the need to have vertex labels arrow tooltip.
Well, no, because that's. I think the problem here is just that automatic vertex labels only works if the vertex expressions are the labels, but they're not here.
Is that
And they
true,
can't be
Ian?
because they're not unique.
Oh, right.
So
So what should you be doing?
This
for
is
that?
just
So
a
it's more
bug in
like a
trace
tree.
graph that it ignores the vertex labels option.
I see. Okay, fine. Because it's really more of a tree-like thing with position in the graph being important as well as the label.
Yeah,
So if you wanna
I was just
analyze this,
using
though-
some trees code to make this, and that shouldn't necessarily be the way that it's done.
But hold on. So if you wanted to computationally look at this tree or this graph, would you how would you get the expressions for the vertices?
Right.
Or would you not?
The trace graph needs to be updated to put them in the vertex labels, and then you could look them up from the vertex labels.
That's kind of yucky.
Well, why
I
don't
think
what
you
we could
should
do
you should
annotation.
define a property. I mean, sorry, an annotation.
Yeah.
That's what I think.
Yeah, so some special annotation in the vertex label will use
Yeah.
that.
Right. But now let me understand. If we had a DAG data structure, would we have this property that you could, like a tree, that you could have things that have positionally specified objects? Does that make sense for a DAG? Because in a tree, obviously,
It's
just the tree
To me, that's
position.
just a graph with annotations.
Well, but
I think the answer to the original question is yes. I mean, like you can define if you have a DAG and it has a root, you can give a path, and that will give you that'll specify a unique vertex, right?
like a tree. Is that correct?
Well, I mean, you guys are always thinking of ordered trees, right?
Yeah.
Probably some kind of ordered DAG too.
Mhm.
Yeah, for sure. Yes.
What's an unordered DAG? What does that even mean?
It just means that the
Graphs, there's no
order.
orders. I mean, it's
Well, right.
like it means it has a single parent. You know.
Okay, but the whole point is here, we've got a root. We've got a distinguished root.
A DAG means it has no size. Directed has no cycle. A tree means
No, I
it has a
understand.
single
I
parent.
understand.
You know, it has nothing to do with order.
I see. So by order, you mean locally, it's like port-like order. At each node, the sequence of edges coming out of that node are ordered.
Yeah, that's what you would need for position.
That's how you think about it from expressions, because like from left to right, the way we write things, that's why we naturally think of it.
No, I understand that. I'm just trying to get the terminology. When you say ordered tree, you mean that there are ports in the sense of ports that we've defined. They're left, right. Every node has a series of sort of as a sequence of edges coming out of it.
Yeah, you have kind of a default naming scheme, like 1, 2, 3 or something, right?
Yes.
Like what we do for positions. There's a default naming scheme, which is numbers.
Right. Which, by the way, probably in the annotations here, Ian, you should be storing. I mean, so what we're basically saying is in the evaluation sequence. Okay, here's a question: is there a coordinate? Is there a natural coordinatization of? And this is kind of interesting, actually, that there presumably is a natural coordinatization of every place in the evaluation graph.
With respect to a given root, yes.
Well, with respect to a given evaluation. So that's a non-trivial thing.
Well,
I'd never really
I mean,
noticed.
if you pick the parent of the node that you want, and from there, there's a unique path from that parent to that node.
No, but what
But if you
I'm
choose
asking,
a different ancestor, it'll be a different path. And so there's not like a unique position specification for each node. There's a unique position specification with respect to some ancestor.
no, wait a minute. You're not getting what I'm saying. Okay, so look, given an expression, we have part numbering that tells one any piece of that, any subpart of that expression, right?
Mhm.
So far, so good.
Mhm.
Yes. Okay, so the claim, which might be wrong, is that what you're showing in these trace graphs is something where every single part here, like that -1 there, is labelable by a definite series of indices. Is that a true statement?
As I was saying, that's correct, with the caveat that it's with respect to the particular ancestor node.
No,
that you
what do you
start
mean
from.
ancestor node? Do you mean this node here?
Yeah, you picked that one, and so there will be a unique path from that one.
But
If you picked a
excuse me.
different one, it would be different.
Hold on. When I have an expression, I've picked a particular expression, and the subparts of that expression are with respect to the whole expression that I have picked. Right? So
Yes.
here, the interesting thing that I'd never realized before, maybe other people had, is that just as there is a part numbering for deconstruction of an expression.
Well, so actually, sorry, there's not a unique path. Like you can go left or right there.
Well, what I want to know is there a canonical labeling of every, intermediate subpart in the evaluation graph?
Isn't this a position in the trace result?
Could be. Yeah, that could be. I'd never thought about that before. I mean, in other words, you can coordinatize this, right?
Just looking at this graph that you have, the DAG that you have in front of you, there's clearly more than one path from fac n to -1 that you pointed to.
Yes, I agree. Yep. But the question is there a good canonical coordinatization of this?
I mean, it's ordered, right? So you can pick, it's an ordered DAG, so you can just pick the left one or something.
Yeah. I mean, I don't know whether that's useful, but it means that potentially there is a coordinate that can be stored as an annotation for every subpart. I hadn't really realized that if you want to label, let's imagine that you've got an evaluation. I mean, right now we've got spatial positions in an expression. And we have rather coarsely defined temporal coordinates that we see, for example, in dollar iteration limit, if that makes sense. But what this is saying is we've got some kind of space-time coordinates that we can define. I don't know, there's some optimal coordinatization of this thing. Does this make any sense to people?
I guess it would give you, I don't know exactly why you would use it, but clearly, even if there are more than one path down to that -1, if you can give one, you can point to it.
Yeah, exactly. Well, I'll tell
so
you
you can
why. I'll tell
highlight
why
things. You can highlight things, kind of like people say with line numbers and whatnot.
Yes, right. So you're saying this is the place where something went haywire. Let's say you're doing debugging. This is, because this is one of the things back in 1990 when we designed Trace. The idea was that you will be able to see the execution of a program in a visual form and point to something and say that's where it went wrong. Okay, so for example, being able to say for an error message, where in the space-time coordinate system of the evaluation graph did this error message occur? That might be a very useful thing to be able to do. Does that make sense? Because otherwise, we have no way to say. I mean, right now, we have no answer to the question of where did that error message occur? How do we describe where an error message occurred in code?
Maybe with a stack trace.
Yeah, but that's not unique. Is it?
But it's more useful.
Well, so every node here corresponds to a held expression in the output of trace. And I think that the output of trace, it's tree structured, not graph structured. But that tree structure has good coordinates, I think. It's just the positions.
Yeah, okay, fine enough. But it's still, as a practical matter. Okay, question. Can we read off the stack trace? Okay, so let's say I'm at this position here. Can I read off the stack trace by looking at the path to the root? I can, can't I? Am I confused? Isn't the stack trace exactly the path to the root?
I think it might be. It would be very nice if that's true. Although, wait, there isn't a unique path though.
Right. It's the path to the root with the evaluation sequence that's being used, I believe.
You're asking about the function stack, not trace.
That's correct. I'm saying in this evaluation, if I look at that -1 when it is produced, what would the stack trace look like at that point?
Not sure.
Okay, was that we should figure it out. I don't know either. And my guess is it is the leftmost.
Redefine fac of 1 to echo the stack.
Fac of 1. Why fac of 1?
Because it's a
okay, I mean
boundary condition. So it's easy to modify the code.
Okay. Just stack open close.
Yep. Might be terrifying.
All right, so let's do this as fac of 3. So should we just do fac of 3 there?
Mm-hmm.
That's extremely uninspiring.
Yeah.
Don't you have to say stack of blank here? That's a little better.
And what's the trace graph of fac of 3?
That's this.
Yeah. But this is this mirrors my intuition, you know. It's fac of 2 and fac of 1. Right? It's like the you know, with no memorization. It's
right.
Oh
my God, what's that? Oh, that's the stack trace.
Yeah.
What the heck is that?
Well, the trace is now much more elaborate.
Oh, I see. The trace is showing your trace graph is including the stack.
Do like a second argument fac
here.
Mm-hmm. Either the symbol or a blank fac. Yeah.
Okay, so there it is. That's the stack trace there, as we expected. More or less. But this needs to be better understood. We're not quite there yet. Okay, so we've got, actually, I want to try one more experiment here, and then we should move on. What I was looking for was one of those unruly, I'm just trying to look, I think I can find it here. There's, let's see. I think I have one here. Does anybody know? I had a nice recurrence that is a kind of an unruly recurrence that goes different distances. Oh gosh, where is it? Must be here somewhere. Does anybody know what I'm talking about? It's a recurrence that has undefined end condition that has, oh come on, where is this? Nobody knows what I'm talking about? Somebody.
Sorry.
Come on. Okay, wait a second. Damn, I thought it was in here. Oh, drat. Well, okay, let's look at one more thing here. I think I may know another place to find it. Let's see. Oh, come on. Well, if all else fails, I know where to find one of these. Oh, I thought it was in there. Hold on 1 second. I've got one other place to look. Ah, I got it. I got it. Okay, here we go. It's this weird function. Okay. Okay, so now I claim, let's take these here. I just want to see roughly what it looks like when we have a non-trivial recursion. Oh no. Oh wow. That's pretty wild. Look at that thing. So that is,
I have a feeling the left to right order is being violated liberally in this.
in what sense? So
Like-
you understand what's happening here. This is a very complicated recursion because it's going back, it's looking back an amount that depends on, you get what I'm saying? I mean, look, in this trace graph, the thing I would like to be able to see is which of these nodes are the end condition.
Mm-hmm.
And this recursion, so I mean, if we do, okay, so let's say we do f of, I don't know, f of 6, just not to live too dangerously. Okay, so what on earth is this doing? I mean, it will be useful to be able to label. So those are evaluation nodes, and this is maintaining.
I think all of those diamonds are where you're hitting your boundary condition.
Okay, but then what the heck is this doing here? What's that doing?
Those are your main definition.
So maybe what I should do is trace graph of f of 2, let's say, or f of 1, to just see what that looks like. And what are those? I don't understand that. Hold on.
You want to trace
that's
original
just
goes to true.
Oh yeah, okay. Why do I need that? Do I need that in this? Okay, so trace original to true here. Okay, and now I want to say, I probably want to say graph aspect ratio 1. What the heck is going on here? Boy, that's complicated. Okay, so what would happen?
So you're
So if
seeing
I-
the evaluations of the conditions as well.
Okay, how would I get rid of that? Can I say comma f here?
Yes.
Okay, so what are those nodes there? Oh, that's the confusing
They were
thing.
something other than F. I'm not sure.
Well, but f of 1 minus f of that. Well, okay, so we don't know what that is. So you're saying up here,
It's probably the same expression, like the F of 1 minus 1 before it's been deconstructed.
okay, so if I go down here,
Actually, yeah,
Okay.
you deconstruct it once and there's just the head F, which doesn't change, and then you deconstruct it again and there's the head plus that doesn't change. So that's why there's those two nodes there.
so what the heck is this? Is this, so if I get rid of this here, and I say, for example, f of 4, for example, f of 3, what is this doing? What is this whole thing doing? So this is f of 3 minus 1 becomes f of 2, I don't quite get it. But maybe what we need to look at here is this thing as a function of n. Now these are much smaller, so I can do many more of them. He says, famous last words. Well, that's kind of cool. I don't know what it means. Let's just keep going just for a bit, just to see whether we can tell what's going on. Okay, well, anyway, so this is a way of understanding some kind of recursion, which is great. And one feature of this recursion, which I don't fully understand yet, is that, you know, for example, if we ask the question, how much of this recursion can be done in parallel? Right? Can you read that off from this picture? Do you understand my question?
So I think the only parallelization that can be read off from the picture alone is the trivial parallelization of evaluate the parts in parallel, assuming no side effects.
Well, there are no side effects here. Wow, this is really cool. I mean, I've never really looked at this recurrence and this. Okay, so that's okay. But so what you're saying is, in one of these pictures here, the foliation line of what gets evaluated when can go where? And Nick is basically saying this is very close to a causal graph, which is what you need to determine what can be evaluated when.
Yeah, I think you have two choices. Evaluate the thing on the left before the thing on the right, or evaluate the thing on the left at the same time as the thing on the right. And
I don't understand that claim at all. I don't understand that at all. I would think I could just put foliation lines anywhere I want in this picture while respecting the
answering your
DAG.
question, how can we determine from the graph where we can parallelize? It's just, do you do a breadth first or do you do a depth first?
Right. You know, Sandra is asking us, can we do, this is going to be utterly, utterly scary to do what Sandra is asking here. This is going to be absolutely frigging insane. At the very best we could do, I mean, this is going to be absolutely huge, isn't it?
I'm not sure.
Well, I mean, this evaluates tons of stuff.
Well, but how much
It
of
might
it
be
is
somehow
kernel
hidden from
code?
trace, in which case it might not be so bad.
Yeah. Or not. Maybe you should have tried
Try
putting a
trace
semicolon
first.
after it first.
Trace gives.
Or yeah, even trace.
It's not even interruptible. Okay, that was a mistake. Okay, we're sort of dead here, but maybe without trace original to true. Well, we're really dead. By the way, you should find out in why it's uninterruptible.
Mm-hmm.
Is it possibly inside the compiler, inside the tree code or something, or does it not use the tree code?
Only for visualization, I'd be surprised.
Okay, well, anyway, so that's dead in the water. So now you're showing various unevaluated things here. So we're going to have to go. I want to.
So actually, I wanted to go look at the next one, which is non-standard evaluation. So after this is all just no evaluation stuff, withholding attributes.
Okay.
Like manipulating held expressions. Yeah. Under non-standard evaluations, you see things that aren't just recursion through an expression.
Oh, you mean the down code is non-standardly evaluating things. Is that what you're saying?
Yeah. So you don't, when you have the deconstruction edges, you're not necessarily looking at the parts of the, like look at the do. Its children are the symbol do, but also the u equal u times u 3 times instead of the literal arguments of the do.
This one here.
Yeah.
That's clearly not the right way to represent this. because
there's 3 subsidiary evaluations.
no, I understand that point. My point is that I think the notion of a deconstruction edge has to be purely restricted to tree recursion. This generator, okay, so
I mean, in general, that's not visible in the from the trace. You just have subsidiary evaluations.
I understand that. I don't know what trace does. It was built in 1990 and it probably doesn't have the right instrumentation. Right. So the fact that this doesn't, you can't get it from trace, I'm sorry. You know, we can go back in a time machine and you know, point out that it wasn't designed correctly. Right. But that doesn't mean we, you know, right now we have this notion of a deconstruction edge, which is essentially the recursion of a val, if I'm not mistaken. That's like the computation being done through a val, whereas here we've got another type of computation that's happening. Am I making sense?
Well, I think they're not so different. You have subsidiary evaluations generally. And
yes, I know, but there's a default subsidiary evaluation for any expression.
Exactly.
And then there are ones that are under the control of a particular head.
Mm-hmm.
Right. And I really think those have got to be indicated differently.
Mm-hmm.
I mean, I don't know, maybe I'm confused, but I think those are different things. I think that what we are doing, what we are about to do is to deconstruct a val, because that's what we're going to need to do for parallelization, is deconstruct the eval operation, which right now we are only seeing in these things. What we're seeing right now is the sequential execution of a val as it walks through a tree expression. Okay? And for example, here, the question of whether these can be parallelized is a completely different question for whether the tree walking can be parallelized. Tree walking is kind of a no-brainer if there are no side effects that it can be parallelized. Am I making sense? Whereas for something like do, it's a complete brainer, so to speak. It obviously can't be parallelized.
Right.
But typically, I don't know. Well, actually, I don't know if it can be parallelized, but it often cannot. So I really think those edges need a different, you know, those are like, okay, an evaluation edge is a pure one expression maps to another expression. This is a case of essentially a control structure where where it's a generation of I don't know what the heck those should be. Okay. All right. Anyway, this is all interesting. I really want to look at Nick's stuff as well. Is there some more? I mean, so we've got to have an invention of some other type of edge here. Does that make sense?
About a dashed edge.
Possibly, yes. Possibly for now, yes.
I think maybe if we make one dashed and one solid, the solid makes more sense for the reconstruction, I think.
Well, deconstruction, reconstruction. Yes, I agree. Because these are edges where things change, right? These dotted edges, the solid edges are merely drilling down, whereas the dotted edges are things where there is a transformation happening. Look, in the end, and Nick, maybe you can say something about this. In the end, these are going to be events. Every one of these is presumably an event. Is that correct? Whereas this isn't really an event.
Right. It's exactly what I did actually when I constructed causal graphs from this trace graph. I just ignored every other edge except those dashed ones to turn them into events.
Okay. So we may need different iconography for this. But for now, we're identifying these different types of edges here. Okay, let's go and look at Nick's stuff. Okay. Okay. I have a feeling Nick's stuff is yet more content. I mean, yet more stuff to look at here. Okay. Did I run the code here? Do I need to run this? I think I probably ran it. What was that beep? Well, who knows what that beep was. Okay. Anyway, let's run this code. Oh, maybe everything crashed. What's going on here? Help.
Hold on, it's just resource function fetching. It usually takes some time.
Okay, fine. Okay, all right. Okay, so let's get a sense of what's happening here. So this is this mostly the world of multi, or this is what are we mostly looking at here?
It is the multi-object. It's this object, like proof of concept object.
Okay, so let's try to understand what this is. So a multi represents parallel threads. I mean, this is what we've got is the sort of a spatial dimension, which is a thing plus another thing, spatially laid out in the tree. And this is kind of the branchial direction of these are multiple threads of execution of this thing. Is that a fair way to say it or not?
I wouldn't say it's it's a thread. It's just a simple alternative values that this particular sub-expression can take. It's like threading, but for general expression, not just arrays.
Okay, wait a minute. Let me understand that. Do you really mean threading? I was meaning threads in the sense of execution threads. Let me understand. Okay, so if I just say multi of ABC, what is that?
That is like an inert object. It's gonna take effect if it appears anywhere in another expression. Like you can just open close brackets, like to make it the simplest one.
Okay, what is that? What does that mean?
So it's like instead of that multi, okay, with 3 threads, if you like, instead of this multi.
Is this picture significant or is this picture just decorative?
No, just is an icon, basically.
Okay,
just
fine. Okay. So now what would I do here? How could I? Okay, go ahead.
We can do a bunch of things. So as soon as you construct this object, it can take multiple values. It can have multiple placeholders. You can query it somehow. It's like you can evaluate it. I have just like a sub value. You ask for a property, evaluate or evaluate list. I already defined a bunch of them. No, you have to first you have to construct it. Leave those open close brackets, for example.
Okay.
And then
I say evaluate.
Yeah. Or evaluate list.
Okay, I'm totally confused here. So this is saying evaluate list. This is a generalization of like replace list or something, where this is saying these are multiple things. I mean, should I think of this like a branchial set of choices, like a multi-way system, where these are multiple things that could happen? And here I'm unrolling all the things that could happen. Is that right?
Yeah, correct. Yeah. If you have a explicit evolution in a multi-way style, this multi-object can represent the whole branchial layer or slice. Instead of just explicit list of states, the whole multi-object can represent this, the whole slice.
Okay, so let me see that in some more real case. So let's imagine that I have my sort of characteristic example where it would normally be like nest graph, n goes to n 2n and n plus 1, for example. Oops, I don't want that. Okay, so I have something like this. How would I represent that in your multi-world?
Well, if your function, for example, would return instead of a list, it would return a multi-object. It's like it's not gonna work for the nest graph, but like maybe. And you also have to be careful because it's a general programming construct, so it will explode as soon as it evaluates inside of any expression.
So can I just do nest here?
Maybe you have to be careful. It's like you can. Okay, that kind of worked.
Okay, so now what would I do to resolve this, to see what these pieces are? Could I flatten it out by just saying?
You can again use open close bracket and then make an expression.
On
Because
this
like
whole
any
thing.
yeah, it's like multi with the listed int, it doesn't do anything. And it's like this placeholder should take some kind of values that also contains multi-objects. So it's
Evaluate
not,
list here.
Yeah.
No, I don't understand what that did.
Maybe try hold evaluate list, because there's some side effects. Yeah, it's complicated. This is a already complicated example. As soon as you evaluate this nested multi-object, it's like,
Okay, but I'm trying to understand what this is supposed to. Okay, so maybe I did a bad example here, but what? Okay, so let's try to understand what this is actually doing.
On the right-hand side where there's the multi of, on the right-hand side of your function arrow, you have n goes to multi. You need another pair of brackets. Multi needs to be inside another expression.
What do you mean?
Well,
But it
what do you
shouldn't
say?
need to be. I don't understand. Why does it need that?
well, that's the idea. It's the idea of this particular object is like you use it instead of values. Like if you have a value in a usual expression, it's just a single value. But if you have a
Yes.
multi-object, it represents multiple values at this particular place of an expression.
Okay, but so in this particular case, I want these two values which are both integers. I don't want the integers with a sub value.
It's like this is correct. It's just we have to think about it a little bit differently. It's like if you have a multi of nested multis, it's like I have no idea what it.
Well, but that's
represents.
making a
Also,
multivector.
it multi, like you can't have multi of atomic expressions. Like,
Why not? Why not? Why not?
No, I'm saying that's what this is doing.
But you should be able to have that. I don't understand why you can't have that. Why can't you have a choice of atomic expressions? I don't understand why multi of list ABC doesn't just work.
Right. Basically, why can't there be a multi-object whose evaluate list is a list of atomic?
Yeah, that's what I'm asking. Right, Nick.
It should work. It's just you have to be very careful. For example, how the nest function works. For example,
Okay,
like
but even without
this
lists,
doesn't work. This doesn't work. I mean, look, what
What
I
do you
would have
mean it doesn't
expected here, this here, how do I get out the list ABC, the set of choices of the multi here?
Well, you can just take first, for example. Well, you just in this case you have to first of evaluate it.
I don't understand. I don't understand. Why can't I just say here, something like list, which just resolves the multi into the list of things that multi could represent?
Because this multi over list is just an inert expression. It's like it has to become something, an object, in order to any of those properties to make sense.
Okay, well, how do I make it? But I mean, why doesn't it just automatically become an object? I mean, in other words, why doesn't this just represent A or B or C effectively?
Because it's not convenient. It's like if you look for the first example, like if you have an expression with multis, you want all those single multis of A, B, C, and X, Y to be just that and nothing else.
But you need a way to resolve them.
No, you have resolve. You make this multi thing, and then you can query it.
Okay, but how do I query this?
Well, this is querying this would make things more complicated. It's like
but I don't understand.
Why don't we start with the example that Nick has provided instead of this wild, nest graph example? Nick has this first one. Let's just walk through that one.
Okay, all right. Okay, which one here? This one here. Why does it need / unevaluated? Okay, I need to see what this actually returns. Sorry, that's not what I wanted. Okay, what is this?
Well, this is an object that contains all those multiple values inside of it.
Okay.
Without actually having
So I want to see without it being okay. So multi of expression. So each one of these, if we wrote this out in multi-space, so to speak, these would each have a stack of possible values in them. Is that correct?
Yeah, it's like if you look at data below, it's exactly what it says. Each placeholder at each particular position has a potential list of values. That's what data for this object contains, and nothing else.
Right, but so another way to represent this would be that I could just draw, just for the sake of understanding what's going on, each of these could be a framed object that has the, a column that says here ABC, and here's this column XY. Is that correct?
Yeah, yeah, you can visualize it like that. Yeah,
that seems useful to be able to see that. I mean, that's kind of like our multi-space visualization of a graph where there's a branchial direction. Does that make sense? Because here, this is more like a token world where we've smashed everything into tokens, and we're simply saying at position blah, it can be this and so on, right?
Mm-hmm.
Whereas the multi-space representation will be something where you still have the structure, but each branchial direction has the choices listed.
Yeah, I accept it as a valid representation. It's like it wouldn't change the object itself, just an additional.
No. I know, it's just a way to. Okay, so I wish. Yeah, I'm trying to disentangle these multiple stacked things. Okay, so this is all the possibilities. This is the resolution of the multi-wayness to give all possible states, right?
Yeah. All right.
So in this case here, what should happen is there should be a way of saying evaluate list of this, which simply gives essentially all these nodes here.
Yeah, just in the nested case, it's a little bit more complicated.
But why? I mean, in other words, in the end, every node here.
Well, let's try to make like nest multi of multi, for example, and see what happens.
Yes.
Like multi of a list and inside the list and some other multi object. And just evaluate it once. And
okay. So now what do I do?
For example, now you make it into expression, because this is like.
Okay, so I just say brackets expression.
It's just open close.
Why? What does the open close do? Is that just a hack or something? I don't understand why there's an open close there.
Because I don't want a multi of a list to make an expression on itself. It's like
I understand, but this, I don't want the thing with the open close in it. I just want this thing here. I mean, I think we need some function that operates on multi-objects that resolves them.
It's like for
right? Rather than a sub-value.
For this particular explicit case, when I have a list of alternatives, I decided not to support it. But like later, when instead of a list, we have a rule, then you can do that. But
I mean, so look, it will be something like, resolve multi or something of this thing, comma, or something, comma, what it's resolving to, right? Because it's just a hack that you have this open close here as a way of signaling that the thing is supposed to represent an expression that can then have things operated on. Is that right?
Yeah, right.
It's not just the open close. Like using it in an expression will do that.
Like +1, you can use inside of any expression. You can add 1 to it.
Okay, so it's a bit of a hack for the. Okay, so fine. It's just a minor hack, so it doesn't matter. But then the whole point here is that now I can say evaluate list. Is that correct?
Yeah.
Okay, I don't understand what just happened here. Why doesn't it give me the list of values?
Because of that nested multi. It's like if you imagine, like maybe I not, because it explodes somewhere in that evaluate list function.
But that's a bug, right? It's
just a difficult case for a nested case. It wasn't my initial purpose.
Okay, fine. But I mean, what this should do is to just, this is like, it's like threading or something like that. It's just like, this should be, the first element should be let's see, it should be A plus 1 is the first element, and then some subsequent element is X plus 1. Am I right?
Yeah, for example, we can just take that list on its own, right? Inside of the first multi, you can just take this list.
Yes.
Evaluate it. It will make you a multi-object. And then you can, what can you do?
Okay, but look, what this should do, I mean, the way to think about it, in my view, is you've got the spatial direction, okay, the fact that A and B are in a sort of spatially arranged list. And then you've got the branchial direction of the multi, which is saying these are alternatives, basically. These are different threads of history. Am I making sense?
Yeah.
And then, so then what we need to do is we need to project in these different directions. So for example, what we could do is we could say, I want to look at a single thread of history. And that's what we're going to do when we want to do like logic programming. Logic programming is going to pull out. I mean, I think what we're going to need is these are explicitly generated multi-objects, which is perfectly interesting, right? But then we also will have, so for example, this could be the game graph for tic-tac-toe, represented as a series of multis. Am I right?
Yeah.
So these multis should be something very much like Ian's DAGs down below. I mean, they don't mean quite the same thing, but they're structurally similar. So then in the tic-tac-toe game graph, represented as a sequence of multis, I could ask a question like, how do I win? What's a path that takes me to winning? Does that make sense?
I don't think they should contain the whole history of a graph. It's like they intended to only record the slice. And then maybe you just hold a list of slices in a different data structure. Just leave it like that already.
But I don't understand why you can get slices. I don't understand. So you're saying, are you saying that this is supposed to be representing what is essentially a branchial graph at a single slice?
Well, in
I don't think that's right. I don't think it's right. I think it's representing the whole multi-way graph.
Oh, if you run it, yeah. You can start with some, for example, if the inside of multi, you had some combinator.
Yes.
You can evaluate it multiple times. Each time you have larger and larger branchial graph. So you have a larger multi-object. But
yes,
you can record any of those sequence of multis in some other place. But I don't think the multi itself should record necessarily the whole history or store it some way.
Okay, but so what you're saying is this expression represents a particular time slice where multi are parallel threads. Is that correct? I mean, if this was a parallel evaluation, we're saying you slice it at a particular time and there are a bunch of unfinished threads there, unfinished execution threads. Do you get what I'm saying? Or am I confused?
Like the data of the object would guide you to whatever next you want to evaluate. It's like contains all the potential.
Yes.
Directions.
Right. It contains all the execution threads.
Mm-hmm.
It is a snapshot of the execution threads. And a different evaluation order would give you a different snapshot of execution threads. It's a different foliation of what amounts to the evaluation graph. Is that correct?
Well, yeah, it's during the evaluation, if you start with a single multi-object that can be parallelized, you follow one or any or all parallel threads, but you can also like restrict only to some of them.
Yeah, I get it.
And it will make a new multi-object, maybe each of them. You can combine them in one again. It's like you can make a new slice.
Okay, so in Ian's pictures, in Ian's evaluation graphs, you could take a slice of one of Ian's graphs and you could write it as a bunch of multis. Is that true?
Yeah, maybe.
I think that has to be true.
It's like trace could be, in principle, I think, just a sequence of multi-objects. Like what pieces of expression are evaluated right now?
I think so. All right, let's keep going here. I'm not completely understanding this. Do other people understand what's going on here? Roger, Christopher, anybody? Ian? Jose?
I think I understand the behavior of this multi thing. I'm not seeing the relationship with trace graph.
Maybe the next, like, okay.
I wish
Because now
you
you
wouldn't do
actually
this. I
have
wish you
also-
wouldn't do this thing where you put these two together because it makes it super confusing for me to understand what the
Okay.
hell's going on.
Sure.
Okay, no problem. Okay, so this is a pattern. I'm just totally confused here.
Well, it's another use case for the multi-object. Instead of having list of alternatives, you can provide any expression and it will extract all the values for it, all the definitions. Like it will make a similar multi-object, but now it records like a rule for each sub-expression.
Right, so what you're saying is, in the standard evaluator, we are just picking a particular path through the application of the rules. Multi is tracking all possible paths of application of the rules. Is that correct?
Yeah, it just looks at the expression and tries to find all the definitions that apply in any
Right.
sequence.
Right, but what we're saying is the evaluator picks the first one. The evaluator is going to return a single expression that is just the result of the first application that works of each of the transformations, correct? Whereas multi is doing all possible sequences of transformations. Will that reach fixed points or not?
No, it's not doing like up to a fixed point, it's just doing a single replacement with whatever definition you have.
Okay, but that, wait a minute. So ordinarily, the evaluator, when it's with definitions, the evaluator will run to a fixed point. Single fixed point. So what multi is doing here is doing one step. And is that, what's the / on evaluated doing?
Well, it's just to not like because set is not holding this multi, it's gonna like make a multi of this set instead. If you're not if you're gonna evaluate it.
Maybe there should be some outer wrapper that you use to contain the multi so it doesn't eat everything, if that's what you're saying the problem is.
Yeah, it's like it's gonna explode inside any expression that is not holding its arguments, including this set.
Including the set itself.
Yeah, the set itself, like the second argument for set.
Yeah, I understand. So it needs some kind of encapsulation that don't let multiness escape from this encapsulation.
Yeah, unvalidated is already perfectly fine encapsulation.
Okay. All right. But then, but what you're saying is each thing, each multi goes, I don't understand evaluation for these things because I don't understand the relationship between the usual evaluator. And I think that's what you're seeing here is a problem between those things. If you had every multi thing, it just doesn't evaluate at all. That thing there just doesn't evaluate at all, but it is encapsulated within a special evaluator, a multi-evaluate or something that is a different form of the evaluator where multi-evaluate can be told, go 1 step, 2 step, 3 steps, and so on, which the main evaluator cannot be told. The main evaluator, once you set it loose, it's going to keep running until it reaches a fixed point.
Right. Well, multi on its own just represents one of these computations. It doesn't actually do them, right? I mean, you can ask for it to evaluate, but that's not inherently what, it's not the only thing it does.
Okay, but it's representing the one step of the computation, isn't it? Not an infinite step
No,
computation.
not necessarily. If it has a property to evaluate it until a fixed point, you can perfectly do that. It's like you can ask for evaluate and provide a number, and to evaluate it multiple times if you want.
Okay, but left to its own devices, it just means, I don't understand this at all. Okay, so what this means is, okay, so again, we're confusing two things in my view, which are similar to what there is there's a multi where you're explicitly giving it a list of possible results. And there is a multi where it is implicitly, as you say here, where it is implicitly, identifying several possible outcomes implicitly from the pattern matching definitions for F, correct?
Oh yeah, it will do it will do this for any sub-expression. You don't even have to have two multis in there. You can just have multi over F.
No, I get it. But there are two sources of multiness.
Yeah.
One is you give an explicit list of things, and those you've defined the threads, basically.
Mm-hmm.
Right? The second case is evaluation of F, special evaluation of F, is a multi-threaded evaluation. It can lead to multiple outputs. Correct?
Yeah, by just the nature of a rule or multiple down values, or just maybe the right-hand side contains.
I get it, but I think these are different concepts.
Right, maybe there should be multiple constructors for multi. One for constructing it from a list, and one for constructing it from down values.
I think one of them is more like a multi from evaluation. This is multi from evaluation, and this is multi from list.
Right. One of them is sort of like non-deterministically pick from this list, and the other is non-deterministically pick from replace list.
Right. And yet another case will be an A vertical bar, B vertical bar, C, which I'm not sure that really, I mean, in a sense, isn't that...
Do you just mean for that to be the same as the list?
Yes, but I think that's this case here, isn't it? No, it isn't, because the pattern doesn't evaluate. It's not got an assignment. Go ahead. I'm sorry. Go on. I mean, because I think there's yet another case, right? Which is similar to the list, is a pattern. Right. So one thing you could do is to say, I want my multi to represent all possible expressions consistent with this pattern, although maybe that's stupid. But with alternatives, that makes sense. But that's effectively what you're doing with the list. Okay, with variable generation, it's more like all possible expressions consistent with this pattern. Yeah.
I mean, can we even compute something? Okay, okay, the all expressions that are consistent with this pattern is a different thing from the replace list kind of thing, right? That's just a completely different thing. It just happens to use patterns.
Yeah, I guess that's right. But it's also
but it's also is there anything we can do with that? Like, I mean, if you say X is any real, is there any meaningful thing we can compute from that?
X is any real.
Well, you can compute it as only structural things. It's like you can just say it's a placeholder, as I had previously. You just pretend that this is a pattern, which is an inert thing that just participates in an expression until you actually need it. That's like the only thing that you can do with it.
But that's kind of different from, I mean, these other types of multi we're talking about. You could actually like do things like, take a random evaluation path and stuff like that, or generate the tree. But you couldn't do that with the, I mean, you basically can't do anything concrete with the, any integer multi.
Unless something concrete actually expects that this is a pattern that is like blank integer, and it can do something with it.
I have to go very soon here. We're I mean, look, the path that I think we're on. Okay, so just to review what we're trying to do here. We've got ways in which branchings can occur. And by branchings, I mean branch shield type branchings, alternatives. And I thought the path we were on is to be able to generate an object that, in a sense, represents the multi-way system of all of the effect of all those branchings. That includes mergings of the branches and so on. Is that right? And that then what we want is various kinds of observers on that multi-way object that say things like, give me the, just give me a path from this starting point to this ending point. That's essentially a proof. Is that right? So, I mean, the thing that I was expecting that we would have is something where what you've got here is a way of constructing multi-way systems, as I understand it.
Yeah, somewhat.
Right, and we've got two different forms of construction. I think we should have three, but anyway, okay. The two forms of construction that you have, yeah?
No, go ahead.
Are the same thing that I was doing with nest graph and that we're doing with our current multi-way system function, which is to say, this concrete state is transformed to this list of states. Right? That's the thing that you can do in one step by just saying it's multi of a list of things. That's what you're doing there. It's a constructor for that multi-threaded piece of the multi-way graph. Does that make sense?
Can you do multi of X where X has own values?
Yeah, you can.
And in that case, like, let's say X had multiple values, 1, 2, and 3.
How can it have multiple values? How can it have multiple values?
So for the own values, you can't, because as soon as you
can have a
assign
symbol with a list of multiple own values.
No, you cannot. You can have no, you cannot.
No, I think you can assemble, like if you set own values
Why not?
yourself, like as opposed to using set delayed, you can do it.
I see. As you explicitly write, own values of X equals a list of values.
Or if you have conditions.
But your left-hand side is going to be the same.
You can have different conditions.
Oh, can you set conditions for own values?
Yes.
Oh yeah, that works then. That should work.
Okay, but
So conceptually, I mean, we can't literally have X equal 1, X equal 2, X equal 3 because it'll just overwrite, I think.
Right, but that's what look.
Conceptually, that's what the list is.
Yes,
right?
that's right. Except that we
like
don't want to.
With multiple
guys, this is going to get totally tangled if you use both the standard evaluator, which has a particular evaluation scheme, and this multi-evaluator. You've got to break those apart. Right? You can't expect to have something where you get what I'm saying? The standard evaluator has two features. It takes the first path and it runs to a fixed point. Neither of those is what you want here.
Mm-hmm. Yeah, I was just trying to understand the multi of a list case in comparison with the multi of a general expression.
Yeah, well, right. You could think about it the way
you can naturally have multiple down values, but
I don't.
Okay, values are tougher.
So, Nick, you had already built a thing that was some kind of multi object that represented the result, where I could feed in a description that would lead to a multi-way system. And then it would produce some kind of object that I could then query. Is that right?
Well, that's the same object, I think.
Okay,
that's
but
the object we're discussing.
What's that? Okay, so I want to know how I would make something that represents, this is the whole point. We want to make something that is easy to program. I want to make something that will do a standard search problem, right? How do I get, like a standard, string-based theorem proving thing or something like that?
Well, Nick and I have discussed, like, we could do something like find replace path with this.
Yes, that's what I want to see.
Yes, but first we have to understand this, which it seems as though, look, We don't have much time. We should have spent more time discussing this object. It seems as though we don't all fully understand what it's doing. But yes, the observers, performing different observer orderings on this, doing find replace path. We've discussed this. These things can be done. But first we have to establish some shared understanding of what this is.
Right. But I'm saying, I think this is multiple things. As it's, in other words, I think there's the explicit giving of these, in the list, which I think is different, really different from the implicit one, where it's coming out from running the evaluator, which is what you're doing here. You're running the evaluator.
Right.
It's not a list of rules. You're running the evaluator to get.
Well, it seems like the object is the same object. They're just different constructors.
Yeah, that's right.
Yeah. And you can mix them basically also.
Right, but I think you should break apart those constructors, because I think there's yet a third constructor, which is a list of rules.
Right, so maybe multi is the object, and then there's, I don't know what to call the constructors, but yeah, there can be as many constructors as you want.
Well, down values is already a list of rules.
I'm sorry?
Down values is already a list of rules, so we don't need like a special constructor for this.
Yes, you do. Yes, you do. Because you do not want to set with assignment. You don't want to use assignment to define these things. Because once you have assignment, as soon as you type it in, it's going to blow up. Right? Like you don't want to use assignment to define combinators, because most of the time it's not going to hold. It's just going to blow the system up.
For convenience, it's nice to have both. I mean, really, the only one you actually need is the list of rules one. And if you want the down values, you can just give it down values of F, but it's convenient if,
No, I agree. Both are
one
useful.
that does that
But
on
I'm telling you, the tangling of the standard evaluator with this is going to be very complicated. Because, for example, in the combinator case, the standard evaluator, as soon as you type S of S of S of whatever that first unbounded combinator thing is, it's just going to blow up.
Right. So this is, by the way, this is this is kind of identical almost to the thing that we talked about, recently and also a while ago about specifying, sort of non-deterministic programs like this. But the thing that we talked about before, there was an outer wrapper, and then there was the inner multi. And I think it seems like having an outer wrapper would make it much clearer where the sort of multi-program specification is versus where the evaluated code is, which might make this less of an issue.
I think so. I think you have to encapsulate it. So we're not doing this hack of open close and things like this, right? Nick, is this making sense or?
Well, there are multiple ways of doing it. It's like, you can, instead of having a list, you can have a symbol with multiple own values.
I know, but we're saying you don't want those things by default. You just want multi to be something like list, which is a completely inert wrapper, and you want ways to construct it. You don't want to have unevaluateds running around all over the place. You just want a way to construct the thing. And okay, that's the one case that you need is some kind of multi of a hold of a thing that is where you want it to be something that has been defined with assignments that would normally run the ordinary evaluator, but you want it to be inside multi. Go ahead, sorry.
But that's already kind of what it is. It holds its first argument. It's not going to evaluate your giant combinator. It's going to hold it, and then you query it with those properties that are supposed to be smart and evaluate it some way.
I think these are purely cosmetic points.
Fine, but we just need a constructor where you can feed in a list of rules, so the combinator is not given by assignment. Because I guarantee it's going to be both inconvenient and it's going to blow up half the time. Does that make sense?
A separate, again, it's separate constructor with the list of rules.
Yeah, sure. Okay, fine. And I claim the list of explicit expressions is not quite the same as the list of rules. We've got three constructors here. We've got the raw expression that would normally be run with the evaluator, but here you're going to hijack the evaluator and do the multi-evaluator instead. That's case one, which is what you've got here as your implicit one. And case two is I'm giving an explicit list of rules, explicit list of expressions. And case three is I'm giving an explicit list of rules, but then I've also got to give an initial expression, don't I? In the case where I'm giving rules, I've got to give an initial expression and the rules.
Well, that's why it's not really a constructor, a list of rules. It's not a constructor. It's the data for this object. It's like if you make a multi over expression, it's gonna like extract all the definition, including down values, sub values, and other kind of values, and make a data for this object with all those rules explicitly there. So if you have your own list of implicit rules, it's just the way of constructing your own data for this object, so that you can feed an expression and just apply those rules.
Okay, well, I'm telling you, the default should not be to use. I mean, it's well, whatever. Maybe I don't know. I doubt that it's going to be useful to take the standard evaluator, because okay, people write code with the standard evaluator to work in the standard way. If we are doing something like theorem proving, we're not going to use the standard evaluator because it's simply not going to work. Does that make sense? So we're always going to want to use something. What's that?
I'm not using the evaluator.
But you are by using assignments. Okay, by setting up assignments, you're doing something where people will have the expectation where as soon as you type in the expression that you're going to feed into multi, without multi, it's going to blow up.
I mean, the point is, if you're doing things with combinators and you're doing things with multi, it's very inconvenient if you have S and K defined, because it means that then when you want to represent combinator expressions elsewhere outside of multi, it's not going to work. I mean, they're going to evaluate.
Right. I think the most common case is going to be that, okay, again, what we could have is a version of assignment that says, don't run this assignment in the ordinary evaluator, only run it in the multi-evaluator. Do you get what I'm saying?
Okay.
Yeah, and maybe in that version of assignment, it'd be more natural to do things like x equal 1, x equal 2, x equal 3.
Well, right. But see, Nick, I mean, that's the point. The point, I think Christopher said that fairly clearly, that we just don't want the thing to have a path where it can go through the ordinary evaluator, because it's going to blow up in that case.
Right. Well, that's why this multi-object is also acts like this export data structure. It tries to not evaluate it as soon like at all. It tries
okay,
to.
Well, that's fine. That's good. That's good. That's exactly what it should do. The only objection here is that in the setup for what goes inside a multi, you should not use ordinary assignment.
Well, or as in there should be a constructor that, that doesn't require assignment.
Yes.
But there should also be a constructor that does.
Yeah, that's fine.
Yeah, we can imagine like create multi that holds its arguments, that creates a multi, and you don't have to wrap it with unevaluated. Like,
yeah, right. But I mean, I think the most common case is going to be, look, what we got to do is some examples, right? Like some, theorem proving type examples, some probabilistic programming examples, maybe a Markov chain would be another good example. Maybe something that can be done with random processes. Roger, do you have a comment there, like a random walk? Right, you should be able to do one of these, which evaluates, generates the binomial distribution, generates a Gaussian from a random walk. Does that make sense? Because the multi is just going +1 or -1, right? You just applied a whole bunch of times, and you should be able to get one observer of that, one observation of that should give you the probabilistic, the weighting of all the elements across that slice. Does that make sense, or did I get confused?
Yeah, it's the case.
So I mean, in a sense, if you were doing that with assignments, it would look like x plus plus, x minus minus. X goes to x equals x plus plus, x equals x minus minus, which it's just super confusing, and you don't want to use assignment for that. Right, but otherwise, what it is hash plus 1. Well, again, I think, I don't know. There's also yet another case, right? There's a case where you're using rules, and there's a case where you're using functions, probably. Like nest graph uses functions. Actually, it doesn't use functions. It uses a single function which has a list result. But I mean, does that make sense? The random walk case, does that make sense as an example?
Yeah, right. It's like maybe like in this combinator example, it's like the result is a list, and it will makes a new multi-object with those alternatives.
Right, but what I'm saying is, remember, what we're trying to do is we've got styles of programming here, like logic programming, where you're trying to get a single path, or you're trying to find one of these paths that satisfies some constraint for its endpoint. Or given the endpoint, find what the path is for theorem proving. Or given, or give me the path weighted list of results. That would be the case for, for the probabilistic programming thing. Does that make sense?
Those are like mostly algorithmic problems. It's like it's just a matter of defining a property that does this. It's not.
I know. That's not the structure. I know, but I think it's important to see, given that the whole point of this structure is to make it easy to do programming, to do essentially non-deterministic programming. I think we have to see these use cases, right, to understand whether the structure is going to work well. That's all I'm saying. Did I miss something here? I mean, I think that's the next step is to see some use cases from the structure. And I think what you're going to find is you don't want this automatic evaluation thing. You're typically just going to want to use rules, I think. It's my claim, at least. But I think you've already built, you've probably already done the hard part of making this work. Okay, James, help me out here. And I got to go in a second here. But I mean, you've been working on, I mean, what is our path here? We've got, there's a multi-way system of possible paths. What are we trying to do here?
Well, I think the first thing is to resolve the points that have been raised during this discussion, like assignments and the constructors from multi here. Okay, then we have a number of these different applications. We've discussed, logical programming, for instance. There's this business of find replace path. There's the business of starting to make this
I know, but we went through these. Right.
Yeah. Well, hey, this is what we've discussed. I mean,
okay, fine. I just think this automatic evaluation thing is going the wrong, I think we don't want this. We really want something where it just is given a list of rules for now. We may want to add in something where it can automatically compile from a set of automatic assignments. That's what I think.
Okay. We'll need to, we'll have to think this through. Definitely.
Okay. Anyway, I mean, but Nick, am I really missing something? I feel like, because usually you produce, impressive things here, and I feel like I must be missing something here.
Oh, well, basically, yeah, we just like turning off this automatic extraction of definition is not a big deal. It's like a matter of just replacing this thing with explicit rules.
Yeah, okay, fine.
I mean, isn't this exactly the thing that we've been talking about for a while?
Which thing?
And now it's implemented. The thing about, specifying. We've called it, multi was the name it was going by anyway. Just the thing for specifying non-deterministic programs.
Yes, I think it is. I think it's exactly this, except for the confusion of the constructors. I think like this thing here.
Like the constructors, I feel like, the main constructor we talked about before was just the list constructor. And honestly, I think it's kind of a, these other things, this is like just, window dressing. Maybe one real question that I might have, but I'm not sure if this could possibly work. There's the question of whether the list can be sort of dynamically generated, like exactly, as you, as it's evaluating. So for example, if you you know what I mean? It's like,
yeah, but that's what Nick is effectively doing. He's got a version of auto-generated. Look, he's got the explicit list, and as he says, it's like the implicit generation of multiness. Right, and the thing I'm claiming is that it's not properly factored somehow, right? The list could have it could be a lazy list that has a list generator, for example, right in it. As opposed to a list, it could be something which says, like a lazy evaluation list. Like, give me all the primes just by generating, range of infinity with some select in it or something.
Or maybe I'm more. I was thinking more along the lines of, can you write multi of select of such and such? I mean, right now I know you can't because it's going to interpret that as the implicit whatever situation. But theoretically, could you write multi of select of blah 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 and have that have it evaluate the select? It turns into a list, and then it does multi of that list. If you get what I mean.
We're going to have to pick this up another time. Okay, to be continued. And I know we've got an LCC meeting in like minus how many minutes, which will also be live streamed. So I've got one thing I have to do before that. So I will